Hi, this is chapter 6, and chapter 6 is about functions. And so functions have the word fun in them, so that makes them fun. This is one of the first videos I recorded for last semester as we went on lockdown. And so I can't believe how many times I say and I think I probably still do that, but anyway. And I also tried to edit out anytime I said crazy things like, email me the word blue or something crazy like that. I don't think I did that, and I tried to get rid of all that kind of thing. Anyway, so if you notice that, but same notes and all of that kind of going along. Anyway, so this is 6.2, and it's on the beginning of functions. A lot of definitions in this chapter, not particularly hard, but it's kind of unusual, and they're just trying to give you a basis on how to go. Okay, so let's go to it. Packet, I'm on the first page, which is Introduction to Functions on 6.1. And they tell us a definition. The definition of a relation. And they say a relation is a correspondence that pairs each element in one set called the domain with one or more elements in a second set called the range. A relation is a set of ordered pairs where the set of first coordinates is the domain and the set of second coordinates is the range. And so we've kind of have seen ordered pairs before, and we didn't have any fancy names for them, but now they're giving some fancy names that go with a set of ordered pairs. So here is on number 2, here is a set of ordered pairs. And so that is a relation. And they're talking about a domain, and they said it was the first coordinates, which is x. And so, and they talk about the range, which they said is the second coordinate, which is y. Now they also said the domain is the possible inputs, and the range is the possible outputs. And so we're gonna answer this first question here on problem 2. They ask us to give the domain and the range, and so we're going to do that. The domain in your book, what they usually do, they write out the word, but I'm going to be a little bit lazy here, and I'm going to say D for domain. And they're going to tell us that equals, and then they're going to have little set brackets is what they're going to use, those little squiggly set brackets. And they're going to put the values for the domain, which are the x values. So 2, 4, 6, and 8 are the values that are going to go in there. And you would put them in numerical order. 2, 4, 6, and 8. So that's our set. Remember, those were set brackets. And our elements in our set. And then I'm going to use a capital R for range, and range is the y values, and they have 1, 3, 5, and 7. 1, 3, 5, and 7 coincidentally or conveniently, they have them in order. They wouldn't have to be in order, and they're not on number 4. And so there we've identified the domain and the range. Now they've asked us, hey, is this a function? And I put what a function is down below here just because I thought I just want to do that first part first and then go on to what a function is. So a function is a relation that pairs each element in the domain with exactly one element in the range. And it's nice to look at this on what is called a function map. So we're gonna do that. So you haven't seen a function map before, but they have them in your textbook, and usually people make them with the oval, and the domain is here, and the range is here. And in the domain, you would put the items you have 2, 4, 6, and 8. And in the range, you would put the items 1, 3, 5, and 7. And then you would draw a line for your mapping. So 2 from the ordered pair, 2 goes to 1. So 2 maps to 1, and 4 maps to 3, and these were coincidentally all in order, but they're not on our next one. 6 maps to 5, and 8 maps to 7. And so each one of the items in the domain maps to exactly one item in the range, and that's what a function is. So this in answer to their question, they asked us, is it a function? And the answer is yes. And I think in the back of the book, they just simply put yes, is what they put. And so we'll look at the next one so that you can kind of see. And so this next one, number 4, the domain, set brackets. Now it's the x values 0, 1, 2, and 1. And if you have any item, any element listed twice, you don't write it twice. So this is going to be 0, 1, and 2. 1 was listed twice, but you notice I've only written it once. And the range, same way, it's our y values, 4, 6, 4, and 5. And I want to write those in numerical order. And I notice that 4 is listed twice. Do you guys see how 4 is listed twice? But I'm not going to list it twice. I'm just going to list it once. 4, 5, and 6 is the range. Now I want to know, is it a function? And so you can do your little function map. And so this is our domain and this is our range. 0, 1, and 2 for our domain. 4, 5, and 6 for our range. And 0 goes to 4, maps to 4. And 1 maps to 6. So all of this is fine. That's all. This looks just like a function. And 2 maps to 4. And that's fine. And here's where the problem is that 1 maps to 5. And so here we had 1, and it was mapping to 6. And now they're saying that 1 also maps to 5. And that's not okay. It was okay that both 1 and 0 map to 4. That was okay, because a y value can have 2 x values that map to it. But an x value can only map to one thing. And so 1 in the x values, the domain, cannot map to both 5 and 6. So this is under function. FCN, my abbreviation for function, is no. Then they talk about the vertical line test. So that's on the bottom of this first page. And the vertical line test says, if it is possible for a vertical line to cross the graph more than once, then the graph is not the graph of a function. And so we're going to come over on the next page here, and they have given us, let me get this lined up, they have given us some graphs, and they ask us, hey, are those functions? And so this graph here looks like a V on its side. It's a triangle there, right? And so if I draw a vertical line here, I hit the graph 2 times. And if you hit the graph more than 1 time with any vertical line that you draw, then it's not the graph of a function. So they asked us here, is this a function? And the answer is no, it's not a function. If you're wondering, well, how does that go with the ordered pair? Well, this x value and these 2 points have the same x value, right? So in our function mapping, those 2 points would have some x value, whatever it is, but they map to 2 different y values, because this y value up here is positive and that y value down there is negative. So I'll call them y1 and y2. And so that's what's happening here, is that they map to 2 different y values. And you can see here that this oval, when I draw a vertical line, hits the graph twice, once here and once there. And so this is not a function either. So no on function on it. And this is a parabola, and we're going to be drawing some parabolas today. And if I draw vertical lines, I just hit the graph 1 time. And so all of my vertical lines hit 1 time. So for function, this is a yes. The next problem out of your book, problem 20, here it is. I got it in the screen. I have to keep looking. My husband's going to make it a little better, he said, for me. They're asking us, they tell us this is a function and ask us the domain and the range. And so we're going to answer those questions. So as we look at this and think about the domain, this is a graph, and so we have a lot of ordered pairs, and I'm just going to write these ordered pairs out for an example. So -2, 0 is an ordered pair there, And then we have another ordered pair that's right there at negative 1.8. Yeah, I'm estimating, guys, at negative 0.2, perhaps. And then there's another ordered pair here, and another ordered pair here, and another ordered pair here, and another ordered pair here. And probably many of you see what's happening is there's ordered pairs in between the ordered pairs that I've drawn. And these ordered pairs continue, right, through 0, 0. And also here at, what is that, 1, 3 is some ordered pair. And so continuing on, and also all the way over to 2, 0. So when we start looking at our domain, it's infinitely many points. Remember, the domain is the x values, and I have infinitely many x values there. I haven't written them all out, but there I have 5 of them, and there are infinitely many. And so, but I do notice this, that the smallest of them is negative 2, right? They're in order here. And the biggest of them is positive 2. And so as I'm looking at that, I can write, and your book writes in fancy, fancy notation for the domain. They say that it's going to be the set of x's. So they make their set brackets, and then they make the up line that goes straight up and down that says such that, and then they're going to trap their x's between negative 2 and 2. So our x's go from negative 2, they're equal to, and so all of my x's are bigger than negative 2, so my alligator's eating the x, and they're smaller than 2. My notes need to be revamped for videoing as opposed to being on the boarding. Now I'm going to be looking at the range. Now the range is the y values, and the y values, you notice, are not in order the way that I've written these ordered pairs. If I wanted to write them in order for the y values so that it was easier for me to see, I certainly can. This is the smallest y value right there, and it has an ordered pair of negative 1, negative 3. And this y value right here, and in fact there are 2 x values that go with that particular this one, and that's okay. That's allowed on a function, right? But that looks like it's, remember I'm looking at the y value. It looks like this first one anyway is at like negative 0.6. I'm not really looking at that, comma, and then negative 2.7. And of course I estimated that value right here. I'm just kind of being really estimating it just to kind of show you. And do you guys agree that all of the y values go from this low of negative 3? And if I was to keep writing ordered pairs, now I know there could be more than one that goes with the y value, and that's okay. I'm only focusing on one because I just want to tell people what the y values are. And remember, I don't write them twice, right? And so all up to here, and the very highest one had a y value. The very highest one had a y value that was 1, 3. That was the highest y value that we would have. So we could make this fancy notation, the set of y such that, and then we go from negative 3, and our y is trapped between negative 3 and 3, so that our alligator shows that y's are bigger than negative 3 and y's are smaller than 3. Now, if you just wrote this in informal set notation as the y's go from negative 3 to 3, like this, without all the fancy, the set of y, I'm actually okay with that. And so, because we're just kind of starting out. And they didn't ask me to say whether this is a function, and it is a function. So now I want to graph these two things. This is number 24, and I'm going to give a graph to these things, and they asked me to say whether or not, to say the domain and the range. So they're now letting me look at a relation or a function. Some of these relations, both of these are relations, and they may, one of them may be a function, both of them may be a function, we're going to see. And so anyway, when because number 24 is y equals x squared plus 1, we would choose our x's because the equation is solved for y. And we're just going to plot some points here, is our plan. And so my favorite point to pick is x is 0. And I'm going to look at the math here on a scrap piece of paper. And so I'm going to get my scrap piece of paper right here. So I have y equals, and then it's x squared, so I'm going to put parentheses squared plus 1. And we just said that we were going to put in 0. And when we do the math there, 0 squared plus 1 is 1. So I'm going to put that right here, 1. And then I'm going to pick another value for x, and I'm going to choose 1 because it's easy. And so I'm going to do the arithmetic here. So the same equation that I had, y equals x squared plus 1, and I put parentheses for where x is going to go. And when I put in 1, I'm going to get 1 squared plus 1 is 2. And I'm going to go ahead and see how I'm out of room on my graph here, and I'm going to make another table here. Y equals, yeah, so these notes were made better for the board and having the sides of the board, and I think that I can fix that up if we have to do another set of notes. I gave you the copies of these, so I think I want to go with it, not to be confusing. And so 2, we're going to plug in 2 rather, sorry, we are on 2. So when I plug in 2, I get 5, right? And I haven't chose any negative values at all. And so I do want to choose some negative values. Now I want to show you something that's kind of, because of the squaring here, if I was to choose -1, do you guys agree that if I came here where I had plugged in 1 and put the negative right inside that parentheses right next to the 1, that -1 squared is exactly the same as 1 squared. So I would get exactly the same y value, which is 2. And if I put in -2, and I just came here and put in my negative, kind of editing what I have a little here, -2 squared, quantity squared is 4, and plus 1 is 5, right? So I would get 5 for this one as well. If I pick 3, 3 squared is 9, and it actually gets a little bit off my graph, so I'm not going to pick that. But it would be okay to pick it. I mean, it's just that my graph only goes to 7. And so there would be nothing wrong with it. And I could pick 4 or 5 or 6. And so when we plot our points, over 0 up 1, over 1 up 2, over 2 up 5, you can kind of see that it makes a little bit of a curve. If you were to grab your handy ruler and you were trying to lay it through there, they're not on a line. It makes a curve. That is a parabola. And when it makes that curve, those are right here we have this parabola going. And it kind of just curves on up. And if we plot our others, -1, comma, -2, and -2, comma, 5. And if we plot these, and so this is really kind of rounded down there, and I made it look more V than I wanted it to make rounded. I'm going to write rounded is what I'm going to write there. That's all rounded. Now they asked us to talk about the domain and the range, and then to say whether or not it's a function. And so I'm going to scoot this up a tiny bit, and then I'm going to put the domain and the range down here below. So domain, I'm going to make it really big. Domain, the domain is all of the x values that we could possibly choose. And you notice that I didn't say what 3 was, but I could have chosen 3. And I could have squared it and added 1, so that would be 10. And I could have chosen 4. And I could have squared it and I added 1. See, 4 squared is 16 plus 1 is 17. And I'd have 17. The reason I didn't plot them is they go off my grid. But they're there, and the same way that -3, and remember the symmetry there, it is 10. And -4 is 17. And so what value would be not okay for me to choose for x? And the answer is, well, you could choose any of them. I mean, they'd go off your grid, but you could see by my arrows that I'm including them there. So there they are going, off my grid. So actually, the domain is all real numbers. And in the back of your book, they write all real numbers. That's how they write it. And so, because I checked. And then the range, it can't be all real numbers, right? And you can kind of look at the y values that we have. 1 and 2 and 5 and 2 and 5 and 10 and 17. And I know there's some repeated, and that's okay in the range. It's okay to have them repeated. And so you notice that the lowest one here is 1. So we're going to have the set of y's such that y is bigger than or equal to 1. And I'm also okay with you just writing this, y is bigger than or equal to 1. That's okay as well. And then they wanted to know, is it a function? And so imagine drawing vertical lines, and we only hit the graph once. And so for function, we would be answering yes. And I hope that's on the screen. Oh shoot, my range wasn't on the screen. So my set of y's such that y is greater than or equal to 1, and to a function, yes, because we said they were bigger than 1. The screen is kind of hard. I'm going to get used to it, and I'm going to do better. And the good thing is you guys are very lovely and nice people, and you are patient. And so I'm going to do my best, and I appreciate all your patience. Okay, so 32 has x equals 3 minus y squared. And the thing about this equation is that it's solved for x. So you want to pick y values. And so when I get my ordered pair table here, I have to kind of be careful. I'm going to get my scratch paper up here. I have to be careful that I pick y value. So my favorite value for y to choose is y is 0. And my equation looks like x equals 3 minus y squared, and I'm going to be putting in 0. So that's 3 minus 0, which is 3. And then I'm going to choose y to be equal to, remember this is our y, and so you can see that my equation saying x equals, it's best to choose your y values. Otherwise, it's too difficult to solve for, if you choose your x values, to solve for y. And in fact, maybe impossible at the level of math that we have, but definitely more difficult than just doing the arithmetic to find the x value. So I'm going to choose 1, and if I do 3 take away 1, 1 squared is 1, 3 take away 1 is 2. So I'm going to add, I chose y to be 1 and x was 2 into my grid here and my ordered pair holder, and I'm going to choose I'm going to choose y is, yeah, you're right, 2. And so when I put in 2 and I do the arithmetic there, 3 take away 4 is negative 1. And it's okay to use your calculator if you need to. And then I'm going to choose x is 3. And so when we do, y is 3. I'm not choosing any x's because it would be difficult. So when I choose 3, I get 3 take away, 3 squared is 9, 3 times 3. 3 take away 9, which is negative 6. So I chose y to be 3, and I got negative 6. In the same way that on our last one, when we chose negative 0 is the same as 0. But negative 1, you have to admit, when you square it, you get the same as you got with 1. So I'm going to put in for my y's negative 1 for the y value. And when I do that arithmetic, I still get 2 for x. And when I put in negative 2, because when you square with the parentheses around that negative, it's a positive. It's the same 2 squared and negative 2 with parentheses squared, quantity squared, are exactly the same. So I get, so negative 2, I get negative 1. And for negative 3, and so this is that symmetry that we had on our last one, -6. And now I'm going to plot all of those points. I have a lot of points. So over 3, 1, 2, 3, up 0, over 2, up 1, over 2, up 1, over -1, up 2, and over -6, up 3. And you can see that you kind of have that curve again. If I laid a ruler through it, no, it is not making a line, right? Even if I go through those two, it's curving is what it's doing. And so this curves here. I don't know why it's hard for me to draw these on their side. And then I want to plot my other points, and you notice that these are some repeats. So we're going to have, I plotted that one. So 2, -1. So over 2, down 1. And over -1, down 2. 1, 2. And over -6, down 3. 1, 2, 3. And here's this side here, and that's rounded. So I've drawn it rounded as best I can. Okay, and plotted those points right off the grid again. I'm going to have to figure myself out a little bit, but I plotted those 3 points and then I drew it in there. And I apologize about getting off the grid. Now I'm looking at the domain, and so the domain this time, you notice that that if we look at the x values, that we have definitely a largest x value, which is 3, is the largest x value that we have there, which is this point right here. And you notice that the graph doesn't go to the right of that point at all. And the domain is like your left and your right. And so how do I, from the left, I can go on forever, right? But the highest I can get to as I go to the right, there is 3. So it is our set of x such that x is smaller than or equal to 3. Our range, this one is a little bit harder for people to see, but just kind of go with it for a second. If you thought about the range is how low does it go and how high does it go, this is very slowly, as this is coming out, if I was to extend it, is very slowly going down and down and down. And it continues that way forever. So it goes all the way to -infinity, as low as you can go for the y's. And then very slowly, this is going up and up and up and up. So the same on that parabola. And so the range is actually all real numbers. And you probably already know about the function question. Is it a function? And am I writing where you can see? I am. Barely though. Oh my gosh, it's hard to keep everything on this grid. Vertical line hits it twice, so it's not a function. So no to function. And so there's that. Okay, so we have just a little bit more on 6.2, and I'm grateful that there's just a little bit more on 6.2. And this one, this problem here, actually, I had to get the book out to read it because it's unreadable. 6.1, if I said 6.2, correct me. 6.1, this problem 34 is not readable. And so I'm going there and I'm going to read the problem to you. And you can go to your book too and read it. The ad shown here was in the local newspaper. Suppose you are hired for the job described in the ad, and then that's what you can't see or read. And it says, espresso bar operator must be dependable, honest, service-oriented, coffee experience desired, 15 to 30 hours per week, $5.25, $5.25 per hour. Start 5:31, apply in person, espresso yourself in the Central Mall. And so you notice that this is a really old ad because you would not be very happy to be making $5.25 an hour. So they say that let X be the number of hours you will work and Y be your weekly gross pay. So what you would be paid for that. And they want us to write an equation, and they want us to include restrictions on the variable X. And so we're going to do that. So we know that if we work 1 hour, we'll get $5.25. And if we work 2 hours, then we'll get 2 times $5.25, right? Which is only $10.50. And if you work 3 hours, how you find your wage is you multiply 3 by $5.25. And so what if you worked X hours? Then to find your wage, you would multiply that by $5.25. So that's actually our equation. Y equals, that was our wage, $5.25 times X. X was the number of hours that we were going to work. So that's the equation they were trying to get us to write. And then they said, hey, are there restrictions on X? And that's the number of hours you work. And if you remember that they said in the book that you could not work, that you would be working between, do you guys remember? 15 and 30. So my X's are going to be between 15 and 30 at this job. So those are my 2 answers. Those are my restrictions there. You could get fancy and put it like in domain notation if you wanted. Then they wanted me, and the next part here is they wanted me to fill out this table. And so we'll give a try to that. So our function rule is Y equals 5.25 times X. And they're telling us to let X, you can't see that at all. So I'm going to write that right here. It's here under function rule, but 5.25, at least I can't see it, X. And then they asked me, well, what about 15? And so this would be Y equals 525 times 15, which equals, and that's going to be under our Y's. So this is our rule. This was our X that they gave us. I've just kind of had to ad-lib it here a little bit, right, in our table. And so all I have to do is take my calculator and multiply 525 times 15. And that's going to give us, making it into money here, $78.75 is how much we would make. And then when we work 20 hours, then our rule would be 525 times 20 equals, and so now I'm going to multiply by 20, and that is $105. And when I work 25 hours, that's going to be Y equals 525. Now I can work other hours besides these 4 that they've chosen. I could actually work 29 hours, and that would meet the criteria of what they said. And so this is 131.4, no, 25, sorry. And then 30, and this is our last one to do. Y equals 525 times 30 is 157.50, and I'm going to write 50 because it's money, is my plan there. And so that was this table here. It's too dark to see. I didn't have a pen bright enough to show on top of it. Okay, then they wanted me to construct a line graph from this, and you notice that my X's just go up by 5. 15, 20, 25, 30, just up by 5. And you might not notice, it might not be obvious to you that your Y values just go up by the same amount as well. 105 minus 78.75, and what they actually go up by is 26.25. So these were easy to see, they went up by 5, and it might not be easy to see that those go up by 26.25, but if you check it out, 78.75, and you add 26.25, you get 105. And if you do that again, 26.25, you add that again, guess what you get? 131.25. And if you do that again, you'll get 157.50. So I'm just going to draw my line graph in here. And I only need to be in the first quadrant, so I'm just going to be in quadrant 1. So these are my x's and these are my y's. And I'm just going to go equal spaced for 15, 20, 25, and 30. And I'm just going to go over here and equal space, because they're up by the same amount, 78, 75, 105, 131.25, and 157.50. And then I'm going to make my dots. So the ordered pair is 15, 78, 75. So here, 20, 105, 25, 131, 30, and 157.50. And then there's my line segment. It's not a line that continues forever, because I'm not allowed to work under 15 hours at this job or more than 30 hours at this job. And so then the next thing is for me to state the domain and the range. The domain, from my graph here, I can see goes from, it's a set of x's such that you could put the equals or the dots. And I guess the book does equals, and so I'm going to try to do what they do. And so they go between 15 and 30. And for my range, it goes, that's the y values, and they go from the low of 78.75 to the high of 157.50. So 78.75, my y's are trapped between, and 157.50. And I'm going to write it 50 because it's money. Okay, oh shoot, that was below again. But I'm just going to raise it up, and I'm going to say what I had, and I really apologize. So I wrote my set notation, the set of x such that, and my x's are between 15 and 30, and my range is the set of y's such that, and my y's are between 78.75 and 157.50. And then they asked, what is the minimum amount you can earn a week at this job, and what is the maximum amount? And so the minimum that I can earn would be the $78.75. And the maximum that I could earn would be the $157.50. Okay, so our best, we're all doing our best. There's videos